This tutorial is all about why we use fuels and indeed what is made when fuels are burned. Here we see a gas ring. We're using natural gas here to produce heat to cook our food. How can we prove that it's producing heat, and how can we measure how much heat is being produced when we burn a certain amount of fuel? We might need to describe an experiment where we show that the fuel produces a certain amount of heat energy. We might need to describe another experiment that investigates what the products of combustion are when we burn a fuel. This past paper question shows an experiment where a fuel is being burned, a liquid fuel inside a spirit burner, and the fuel is being used to heat up a certain volume of water, a certain mass of water, usually 100 cubic centimeters, which weighs 100 grams, and a thermometer is being used to measure the temperature before and after heating. Of course, to tell how efficient a fuel is, we'd also need to measure something else, and that would be the mass of the burner before and after heating. The difference between those would tell us the mass of fuel that's been burnt in each case. So long as we keep the same mass of water, we use the same temperature rise, we can tell which is the best fuel by the one which uses the least fuel to produce the same amount of energy. Alternatively, we could burn the same mass of fuel in each case and see which one gave us the biggest temperature rise, which would give us the biggest amount of heat energy produced. This question uses the second of those two options. It says, look at the table. It shows some temperature changes when equal amounts of three fuels are burned. Well, we can see that there are four columns: the name of the fuel, the temperature at the start, the final temperature at the end of heating, and the temperature change. And it's quite straightforward that the temperature change in the final column is made by taking the initial or start temperature away from the final temperature to find the difference. You're asked to find the difference for fuel C, so we simply take 33 and we take 22 away and we're left with 11 degrees, which we might write in the table or indeed in the answer. Which fuel releases the most energy? Choose A, B or C. Well, all three of them are burning the same amount of fuel, but the one which produces the most energy will be the one with the highest temperature change, so that would be fuel B. When a fuel burns, it releases heat energy. Look at the list. Complete the sentence, choose from the list. Heat energy is measured in. Well, energy is measured in joules, so heat energy is no different. It's measured in joules. This is a classic school science experiment to show what is produced when a fuel is burned with plentiful air. What we have on the left-hand side is a fuel cylinder which is being burned, and then the gases which are being produced from that flame are collected through an apparatus and sucked through there by a suction pump on the right hand side. So the products of burning are both vapours. We can see that they're not solids or liquids because we don't see anything dripping down off the fuel when it's burning. So the first thing that happens is that these products are pulled through the first tube. Now the first tube is cooled down in some ice, and that is going to condense any vapours which condense at reasonable temperatures, and what happens is that we get a liquid collecting in this first tube which will turn the white anhydrous copper sulfate to a blue colour. There's an alternative substance that you can use for testing for water, and that's cobalt chloride paper, which turns from a blue colour to a pink colour. So the first product that's collected is water, which is originally water vapour. However, another product continues, doesn't condense there, and continues and bubbles through some lime water. Lime water is used as a test for carbon dioxide. Indeed, this lime water will turn cloudy, showing that carbon dioxide has been made. Any remaining substances, some air for example, is still pulled through to the rest of the apparatus. In terms of the answers then, the anhydrous copper sulfate went from white to blue, proving that water was present, and the lime water went from colourless to cloudy, or I guess milky, proving that carbon dioxide was present. And the products of combustion therefore are carbon dioxide and water. So when a fuel burns, it burns in oxygen. And because the fuel is a hydrocarbon, contains carbon and hydrogen only, the carbon part burns in the oxygen to form carbon dioxide, and the hydrogen part of the fuel burns in the oxygen to produce hydrogen oxide, H2O, which is water. All fuels, when they burn in plentiful supply of oxygen, will all produce carbon dioxide and water as their products. And here's a related past paper question. It says, look at the diagram, it shows a hydrocarbon fuel burning. The chemicals made when the fuel burns go through this apparatus. Well, it's broadly similar to the one we just looked at. We can see the fuel here they're using is wax, but that's a hydrocarbon as well. We've got a U-tube in the middle, which is again surrounded by ice to cool it down, but no test substance in there. And then on the right hand side we've got a second tube where a gas is bubbling through. We've got tube A, which is the U-tube, and we've got tube B, which is the tube with presumably the lime water in it. Tube A is surrounded by ice. A colourless liquid slowly collects in tube A. Write down the name of this liquid. Well, that would be water. And the liquid in tube B is used to test for carbon dioxide. Write down the name of the liquid used to test for carbon dioxide. This would be lime water. Another question from another year. Some camping stoves use propane, C3H8, as a fuel. Complete combustion happens when propane burns in lots of air. Complete combustion of propane makes two substances. Which two substances? Choose from the list. Well, these two would be, as before, carbon dioxide and water, but of course we'd have to write those in on the answer line, so the answer would be carbon dioxide and water. So, in summary, complete combustion, that means the burning of a fuel with plentiful supply of air or oxygen always produces two products, carbon dioxide and water.